Hey everybody. This is about ranking the brightness of bulbs, which you've done in the past, but more importantly, what happens if one of the bulbs goes out? How does that affect the other bulbs? So what I would suggest is that you take a minute when I'm done talking, pause the video, and just kind of get this all on a piece of paper because we're going to be answering the questions on the left, ranking the bulbs, and then what happens if each bulb goes out. So take a second, pause the video, and now you're back. So one of the important things we're going to do for all these problems is we are going to assume that all the bulbs have the same resistance. So that makes life easier. If they didn't have the same resistance, this would be exceedingly difficult. Now, knowing that, I'd like you to answer questions 1 through 6 on your own. Just take a wild guess. I know you can do number 1. You've done something like it before. But if bulb A goes out, what that means is that bulb A goes out, like it's gone. There is now a break in the circuit there. What will happen to the other bulbs? Okay, I got to put that light bulb back. So we'll put that light bulb back. There you go. And the options are that other bulbs can either go out, get brighter, or get dimmer. Those are the only options we're going to do. The other bulbs go out, get brighter, or get dimmer. So please, give it a shot. Who cares if you're wrong? Pause the video, and then come back. And now you're back. So here we go. I assume when you did the brightness ranking that you have that A equals E, and then D is the next brightest, and B equals C. By this point, you should know if you treat these all as 1 ohm light bulbs, that this has a resistance of 2 and this has a resistance of 1. Therefore, when the current reaches this junction here, more of the current will go through the 1 ohm resistance path. So I assume you knew that. But now let's do the rest of this. So if A goes out, that should be pretty straightforward. I hope you got that one right. If A goes out, there is a break in the circuit here. If there's a break in the circuit, current can't flow. So if A goes out, they all go out. There's a literal break in the circuit. So the same thing, all go out. Same thing could be said if E goes out. Let me put the light bulb back in here. Now if E goes out, we are breaking the circuit right, oops, not that whole circuit. Holy cow. So we're breaking the circuit right there. Now, some people would say that, well, can't the current still flow through this part of the circuit before reaching here? The answer is absolutely not. If you're not connected to both sides of the battery, there's no electric field in the wires to push current. So once you break the circuit, there is no current flowing. So in that case, also, they all go out. And now I got to put that light bulb back. So put the light bulb back. All right. I might as well go with the order. If B goes out, okay, so we're going to remove B. B is now gone. Hopefully you guessed that C would go out. I want to use blue. C goes out because the current can't flow to it right now. And then D. Now D is going to get brighter. So I just put an arrow up. I didn't write D brighter, but you can. I'm just lazy. I'm putting D up, meaning it gets brighter. Here's the reason. Originally, the current came into this junction here, and it split. Some of it went up here through BC. Some of it went through D. Now BC are gone, and D doesn't have to share anymore with BC. So D gets brighter. It's really, oh boy, it's really that easy. That's better. So D gets more. Now the real question is what happens to A and E? As it turns out, they get dimmer. There's a few ways you can look at this. I also have to put light bulb B back at some point. But there's light bulb B. A few ways you can look at this. Originally, this voltage source here was feeding current to 5 light bulbs, and all that current had to go through A and come back through E. Now, we removed 2 of those light bulbs. So now the voltage source doesn't have to feed all 5 light bulbs, only has to give to 3. So it doesn't have to give out as much current. Therefore, A and E that got all the current now get less current because the voltage source is not supplying as much. Now, the other way to do this is to think of it in terms of equivalent resistance. If we were to quickly do some math and say that this is 2, this is 1, and we put those 2 in parallel, that becomes 2/3, and then we add the A and the E. What I mean by that is our equivalent with all the light bulbs here is the 1 from the A, the 2/3 from the BCD area, and the 1 excuse me, from the E to give us 2 and 2/3. So what happens when we remove BC? So BC is gone, and we can trace the flow of current. Now it goes through A, through D, and back through E. So when B and C are out, our equivalent is just 1 plus 1 plus 1, which is 3 ohms. So what's happened here is that the resistance, our equivalent, has gone up, so the current coming out of the source must go down. If that's the case, anything getting all the current, like A and E, if there's less current coming from the source, they get dimmer. So hopefully one of those 2 explanations sits well with you. All right, if C goes out, it's pretty much the same thing. Again, if C goes out, we are cutting the circuit there. There's a hole. So if C goes out, B is definitely out because the current can't flow up there. Again, D does not have to share with BC anymore, and it's like more for me, so it gets brighter. A and E will get dimmer. Same logic as before. I'm going to put bulb C back in here. So maybe at this point, it's clicking a little better. So what I would suggest is before I do the answer, maybe you figure it out. What happens when D is removed? I would say what happens to BC and then what happens to AE. So give it a shot, pause the video. And now you're back. And I'm hoping you said when D goes out, again, D is gone. There's a hole there. That means B and C no longer have to share with, D. So that means B and C would get more. And we have removed a mouth to feed, if you will, so that the voltage source doesn't have to supply to 5, it only has to supply to 4. So that means that A and E would get dimmer. The other way to look at it is we have removed a bulb in parallel. Now, I don't know if you remember, but adding bulbs in parallel makes, or adding resistors in parallel makes the total resistance go down. So removing one in parallel makes the total resistance go up. Here's the proof. Trace the current as it goes around. It goes through A, B, C, and through E. Basically 4 bulbs in series. So when D is out, our equivalent just becomes 1 plus 1, if I can write 1 plus 1, plus 1 plus 1, which is 4 ohms. Again, 4 is greater than 2 and 2/3. So the R equivalent has gone up. Current from the source has gone down, which means anything getting all the current is now dimmer. Sharing takes priority over anything else, though. You may be saying if there's less current, why are B and C still brighter? Because they don't have to share. Please trust me on that. If you want, make up your own circuit and prove it by solving all the currents and voltages in it, and you would see the same thing. So that's how you do it. I'm going to prove this to you really quick, so give me a second. I'll be right back. All right, so we're back and we're on that circuit construction kit that you used at the beginning of this topic. I've built the same exact circuit that we were just discussing, and you can see that A and E are the brightest, then D, then B and C are the dimmest. But let's prove what we were talking about before. So what I'm going to do is I'm going to remove this light bulb. Can I remove it? Yeah, it's gone. And as you can see, the circuit is cut. And when the circuit is cut, there is, oh boy, what happened here? There's no flow. And I hope you understand that if I do E, it's the same thing. The circuit is cut. All the bulbs will go out. So I will put that bulb back in here. Why does it do that? I have no idea. All right, let's start with getting rid of B or C. So if we get rid of B, we know C is going to go out, but the most important thing is watch D and watch A and E. We said that D would get brighter, A and E would get dimmer. So here we go. And as you can see, that is what happened. If you didn't see that, let's do it one more time. I'll remove this bulb, watch D, watch A and E. D gets brighter, A and E gets dimmer. And there it is. So let me put that light bulb back, and we have one more. We said if we get rid of D, that BC should get brighter, AE should get dimmer. So here we go. Remove that puppy. Watch the two above, they should get brighter, and then A and E should get dimmer. Yep. And that's it. We usually do this in a lot more detail, and we make it a lot more difficult, but because of our situation right now, we're just going to leave it at this. So I hope this video was helpful, and you know what to do. If you need help, please hit me up for office hours. Did I just say hit me up? I'm 45. I shouldn't be saying that. Anyway, I'm available for office hours, and I hope everyone is doing well.